in defense of EIGRP. In defense of? Does it need defending? Some of you might ask, and others of you are daring us to have a discussion that successfully defends EIGRP because in your minds, there is no defense. Well, no matter which side of the divide you fall on, we are having this EIGRP discussion. We're going to go through major use cases, design considerations, a few scaling tips, and more. And our guest today is Zig Zsiga. And you might know him as the voice of Zig's Network Design podcast, where he discusses how to think about network design with guests and friends from all over the industry. And Zig and I know each other kind of in this way. We know each other from the internet. And you might remember him from Heavy Networking episode 555, where we discuss the top network design trends of 2020. Actually, a really popular episode based on download numbers and stuff. So Zig, hey man, welcome back. I know from listening to several of your podcast episodes on your network design podcast that you are an EIGRP fan. So dude, we got to first address the elephant in the room here. We're going to jump right into the discussion. I want to know from your perspective, why does EIGRP have a bad rep? Is it like the Cisco proprietary thing? Is there something more to it than that?
Yeah. So thanks for having me back as always. I appreciate it, Ethan. Yes. So I am a big fan of EIGRP, as you're aware. And I would say, I think it's situational. I think it's experience-based initially. I think it's probably based on your personal experience and what you kind of started using as a routing person, right? If you're using OSPF or EIGRP in those first few years in the career, I used EIGRP and I fell in love with it, right? I fell 100% in love with it.
So the bad reputation part, in my take, you work with you work at Cisco. You deal with a lot of customers. I think in the federal space especially, right?
That's correct. You got it. Yep.
So okay, so to me, the whole reputation of EIGRP being bad is like you got it because some Cisco partner walked in the door and that's what they knew, and so they threw it in there and you're kind of stuck with it. But the real world uses OSPF because interoperability. Does that sound about right to you?
No, it does, right? So that's usually the use case is hey, we have to interoperate, we have to work with other vendors, right? We have to work with other hardware, other solutions, and so we can't use EIGRP, or we have to do redistribution. Heaven forbid, right? Heaven forbid redistribution between protocols. I think it's situational. I think there's some good use cases for EIGRP, but I do think EIGRP has some bad rap. Like people that have done OSPF for years, most likely are never going to use EIGRP if they're very fond with OSPF. They haven't had any issues with it. OSPF functions, right? OSPF works, especially if you design it effectively and correctly at scale.
Well, okay, so now you just hit on something pretty interesting here. OSPF at scale does get to be, you have to have a deeper thought process as you're doing that design. You've got multi-area, you've got a backbone area, you've got to think about where your ABRs are, you got to think about where you're going to do route summarization, or if you're going to do route summarization, you need to think about a lot to make sure multi-area works like you want it to do, and you don't make mistakes like one of my very first OSPF challenges I ever ran into was a network that I didn't build and I inherited, where the network, when the main line went down, an ISDN backup line came up, only it didn't come up in the backbone area, it came up in this other area, and all of a sudden I got all this traffic converging across this ISDN line that would get very full, which takes away from our discussion about EIGRP, because my point is OSPF, as capable as it is, you do need to apply a lot of careful thought, especially as you get into a lot of routers and a number of areas, to make sure it functions as you want. It's not the easiest thing to get right.
Well, you touched on a couple of things, right? So EIGRP is honestly easy. In most cases, I would call it easy. You can kind of just configure it and walk away in most cases.
Well, dude, especially
these
joke?
Days.
Router EIGRP1, your network statement, and just walk away.
Walk away. Auto summary is enabled. Everything. You're done. Out the door, right? Like that's, and here's, I think I put it in the notes, man. So I was in the Marine Corps and I had a junior Marine configure EIGRP, and he configured it with auto summary enabled and all these network statements. I mean, he probably had 100 network statements in the EIGRP configuration. And so I went up to him, and I know EIGRP and I know how it works. I'm asked him, like, so why'd you do this? Like, what was your reasoning for this? He's like, oh, this is just what they taught me to do, in school. Like, this is why I was told to just add all the network statements in there and the entire network, and I'm good to go. But that example shows that you can misconfigure EIGRP because that's misconfiguring EIGRP, but it's still going to work, right? It's still going to function. And there are some issues, right? There are some nuances, and we'll get into like stuck and active, which can still be an issue, but there's a lot of flexibility that you get with EIGRP. OSPF is great. And I would say that, as you scale up with OSPF, you really have to design it effectively, right? You can't just store everything in area 0. Initially, you can, right? Initially, small scale, totally, you can. Throw it all in area 0, good to go. You don't have to do any type of summarization or segmentation of the LSAs. But as you ramp up devices in that area 0 and all those routes and all those LSAs, you're going to have to design it effectively. EIGRP is a little different, right? Like, you don't have to design it per se out the gate, right? And there are some mechanisms that you can leverage to design it, but like you can summarize on the spot with EIGRP. You can't do that with OSPF. Today, right?
Yeah, this is the difference between a distance vector and a link state protocol.
Exactly.
Link state, everything in that area needs to know what every other router knows, so that they all make the same calculation and the forwarding is consistent. Distance vector, you can summarize wherever you like.
It's such a great requirement. Like it's a solution to requirements, right? If you're designing a solution for a customer or for your own environment and you have a need to summarize, I mean, EIGRP is such an easy way. Hey, I can summarize in any interface I want. Like, it's an interface based summarization. Now there's some caveats to that, right? You have to actually have an IP addressing scheme, a subnetting scheme that can be summarized, right? You can't, in most cases, you could summarize a default route. Yes, but like, that's not going to help you here is what I'm trying to say. But like, if you don't have like your network IP address scheme created as like a plan, then your summarization is not going to solve anything, right? So that's the other caveat or requirement to doing summarization.
Well, so I think one of the principles, or one of the ideas we're relating here, Zig, is EIGRP has got some flexibility and some forgiveness kind of built into it, inherent in its nature, how it converges, how it computes, shortest path between endpoints, whereas OSPF, which again, just about everybody's using that, is more, I want to say rigid, but kinda, you really need to understand the roles of routers and areas and therefore set them up appropriately. Nonetheless, Zig, EIGRP is, and why we're having this conversation in defense of EIGRP, would you say it's being displaced by OSPF and maybe ISIS?
I don't think so. I mean, I still have customers that use EIGRP every day, right? Like, I have customers, that's all they know. They don't even know OSPF. And I know that that's weird to say, but that's the truth. I have customers that know EIGRP and BGP, and that's it. And I have the flip side. I have customers who know OSPF and they don't know EIGRP. So again, I think it comes down to, what you're experiencing when you get into your career field and kind of that first couple networks where, you see that IGP, that your first IGP. I mean, can you go back in the day, and I'm going to throw this out there, and remember your first RIP environment, right? What were your thoughts about RIP and RIP version 2, right? Version 1 and version 2. Shoot, I'm sure most people that listen don't even know what RIP is anymore, right? Or I'm dating us, right? But that's the point I'm trying to make. Like,
my first thought was, why does this converge so slowly?
It takes forever in a day, right? Like, or and then a hop count. You get 16 hops later, and you're pretty much black holing traffic, right? Like, there's no, this isn't a RIP show, but I was just trying to say that. Well, rest in peace, RIP, right? But sorry, I had to do it. But the point I'm trying to make is that I really think it's experience based, right? You go into an environment, someone else already had it there. Now, from a choice perspective, you're designing a greenfield environment. I always go back to the requirements. What are you trying to achieve? What are you trying to, deal with? And what's your topology? There's some topologies that work well with EIGRP that don't work well with OSPF, and vice versa. Think of hub spoke topologies. Like, a hub spoke topology is going to work better at scale with EIGRP than it will with OSPF. Now, I'm not saying that you can't. There's going to be people that say, well, no, I have OSPF working today. I'm running DMVPN or whatever, a full mesh of, or not a full mesh, a hub spoke mesh of GRA tunnels. Yes, you can get OSPF to work that way, but you got to think of the protocol under the hood. Everything's in the same area, right? Like, and if you have 1,000 routers, all those routers are now in the same area. Every time an LSA change happens, every one of those routers is getting that update. Just think of the flooding mechanisms with OSPF.
I actually gave up trying to get a DMVPN with full mesh working with OSPF and went to EIGRP for partly for this reason. Yeah.
Yeah, so I think that's a good use case, right? And actually, that's a good conversation that we have.
So
in my
wait a minute, we got to
Discord
dig
server all
into
the
more
time.
use case. We need to dig into more use cases here, but you just said something huge. Even in Greenfield today, in 2021,
Yep.
you Zig Zsiga, CCDE, and Cisco Human will sometimes specify EIGRP. It's still a viable option in your mind, depending on use case.
Oh, for sure. I mean, there's a lot of flexibility with EIGRP. You don't get it with OSPF, right? Like, think of like just building out an environment to mitigate failure domains. And I'm going into like design techniques and design principles, right? Failure domains and kind of limiting your failure range or your failure reach is critical. Think of the days when we spanned layer 2, right? We span layer 2 across all the boards. Well, think of that issue, but at a layer 3 perspective. We have this OSPF area 0, and how big is that OSPF area 0, right? That's a very, very large failure domain. And then let's add another area to that, right? Let's add a not so stubby area where we're going to redistribute routes. Well, all those redistributed routes now are going to have to get propagated to all those routers in area 0. So again, I would harp, right, that if you can design OSPF and you know the area types, you know the areas, the LSAs, and how to filter LSAs, right? Because to your point, that DMVPN solution, you can get OSPF to work on DMVPN. Yeah. You just got to use some techniques like LSA type 3 filters. And there's techniques to do it, right? That's what I'm coming down to. But you have to design it appropriately. There's more design upfront work to get OSPF to work everywhere. EIGRP, man, you can just throw it in there and it's going to work in most cases. Now, when you have those very, very large EIGRP topologies where your timers are going to go out of, your timers are going to, what's the word I'm looking for? They're going to time out before a response to a query comes back. That's where you're going to start to see issues, right? That's where you're going to start to say, hey, that's stuck in active situation. And that's all about designing effectively that query process, understanding how EIGRP works with query. Why is it querying, right? But here's a good caveat or benefit of EIGRP. Natively, EIGRP has, it selects a route, right? It's going to have a route. It's going to select it. I'm not going to specifically use the terms that EIGRP uses by heart. It has a route. It's in the routing table. It's going to automatically set up a backup route. And it's going to inject
successor and
that
feasible
well.
successor.
Exactly.
I'll use the words. Yeah.
Yeah. Those are the words, right? Successor and feasible successor. But it's going to automatically choose that route. OSPF doesn't do that natively, right? That doesn't happen. So the fast convergence that you get with EIGRP is because if there's redundant paths or there's multiple options, it's going to install those into the table. It doesn't actually do the query part of the process. It just says, hey,
you're saying if it has a feasible successor in the table, when the successor route is withdrawn for some reason, the feasible successor can take over immediately. You have a very fast convergence.
Yep, exactly. You're right. And I should have probably gone into detail on that, right? So yeah, it's an immediate failover, right? That successor goes offline. And then the next, it says, hey, do I have a feasible successor? Oh, you do? Okay, well, I'm going to pop that into my routing table. And that's it. Like, that's the process. Now, if it doesn't have a feasible successor, then it does the query lookup. It sends out a query to all the routers saying, hey, in my EIGRP domain here, do you guys have a path to that network? Right. And so it's going to reach out to all the neighbors.
Do you know? Do you know? Do you know? Do you know? Yeah.
And that's a recursive, right? That's a recursive process. It's going to go through the next neighbor you ask is going to now ask his neighbors or her neighbors, right? And so on and so forth until a response comes back. But that's where you get that query process and that query timeout. And so things like
you're heading towards the stuck in active problem.
You got it. So things like using stub routers, right? EIGRP stub routers to mitigate the query domain. The summarization we mentioned there a few minutes ago, that's going to also help mitigate that query domain.
Okay,
Like the
I want to talk
size of the
about
query
stub
domain.
routers in some detail, but dude, we're like winding all over the place
I'm
trying to have this
sorry.
conversation. So okay, I want to go back to the greenfield
Yep.
discussion and then build on that. So you've made a very good case that even in greenfield, where you're doing a brand new network, layer 3 EIGRP as a routing IGP and underlay routing protocol, there are definitely topological use cases that might drive that as a decision, presuming you're building out a Cisco network, which of course we know many people are. They're building a Cisco network. That's what's out there. All right. You cited one topology specifically where you liked EIGRP, hub and spoke. We know what a
Mhm.
hub and spoke looks like. Okay. Um, Other things that you've mentioned here, just the flexibility where we can do summarization and stuff, that might matter a lot depending on our IP addressing scheme, depending on where we want to. I think you're going to be a border router or a boundary router of some kind, and it can be somewhat arbitrary where that is. You've still got the ability to do summarization, assuming your addressing scheme is going to allow for that. Because, of course, Zig, we all have outstanding, well thought out
Yes.
addressing schemes that are going to just do great with summarization.
Yes, we do. We do, right? We're not using single IP addresses in single places. We don't do that.
So, so are there any other major like use cases where you'd be like, given the choice, I'd pick EIGRP in this scenario?
Yeah, so I would pick it probably where I needed very fast convergence, but not like sub-second or nanosecond convergence. You know, they're native. Those we talked about the successor, and I kind of jumped around, and I apologize for that. My mind is that way. That's how my mind works. But the successor and the feasible successor, that built-in capability of EIGRP, it's already there, and you don't have to do anything about it. You don't have to configure another feature or another protocol or calculate like fast reroute or loop free avoidance. There's a whole bunch of technologies that you could do that you don't need to do with EIGRP. So you limit the complexity level, right? You're just running one protocol. It has that native high availability, if you want to leverage the term, right? High availability, built in redundancy. And so like if there's not a requirement where I have to run OSPF, and there's benefits to run OSPF, there's benefits. Like, if I don't need traffic engineering tunnels, if I don't need any type of TE, right, then I don't need to run. I can run EIGRP. So that is a limitation with EIGRP, is that you can't run natively traffic engineering tunnels within like MPLS, like MPLS TE, with EIGRP. But you can with OSPF and ISIS. So there's some benefits there running OSPF and ISIS. So if I'm in like a campus architecture or even a data center space, and the requirement is, hey, I have to run TE tunnels, and oh yeah, we're running MPLS as well. Well, then I'm going to rule out EIGRP.
Mm-hmm.
But if I'm in a campus environment, and let's say we have a layer 3 access design, meaning that we're running layer 3 services on our access switches, and our access switches are where all the devices are plugged into,
Mm-hmm.
and we have redundant links to the distros and redundant links to the cores. I'd probably run EIGRP. I have redundant links, right? I have equal cost multipathing going on. It's fast convergence, right? It's simple to summarize. But then, if I had to run OSPF there, it's all about your area design, right? So that's you have to add that step in. Whereas EIGRP, I can say, hey, our summarization, our subnetting scheme is here. Here's EIGRP, put it on, and now you're done.
Hmm. One other qualifier worth making, Sig. We said, or I said just a little bit ago, we're making the assumption this is a Cisco network.
Mm-hmm.
That's the full-blown EIGRP implementation. That's where you get all the features and the nerd knobs, if you will. Not that we like nerd knobs unless we have
Love
a use
nerd
case.
knobs,
But
man.
that said, Cisco with RFC 7868, it was an informational RFC. Hey, world, here's EIGRP and the basics of the dual routing algorithm. And you didn't get everything in that spec. I think stub routing was one of the things you don't get in that spec and so forth. My point, though, you do have EIGRP not merely Cisco proprietary. It has been, to some degree, opened up and made available to the industry. Does that impact anything in your mind? Do you see much industry uptake where anyone actually cares that that's a thing that's happened?
Uh, I have not, in a production environment, I have not seen it. That doesn't mean it doesn't exist. So, my purview is, relatively small, government, federal space currently, but I have not seen it used by other vendors yet. That doesn't mean they don't. That doesn't mean that they can't. I was extremely happy personally that EIGRP had that. There's an RFC for it. I'm a little bummed that they didn't include the stub feature set, right? Because that's if you start to hit those scaling limitations with the query domain, right? Like, and you're going to get stuck in active, like that stuck in active situation,
Yes.
which is, to be honest, the biggest issue with EIGRP is that stuck in active. Right?
Absolutely. Yep.
Without stub, so just to be clear, EIGRP stub routing is very similar to like a stub area type in OSPF, right? So we can limit what routes we're sending out. So that's the first thing. We're going to receive routes from our neighbors. So if I'm configured as a stub EIGRP router and Ethan is not, right? Ethan is a normal EIGRP router. I'm going to receive all his routes.
Yes, I knew I could be normal. Yes.
So you're a normal person. I'm not, right? I'm stuck. I have to have examples. That's just how I do things, right? So I'm going to receive Ethan's routes. So all the routes that Ethan has, I'm going to receive them, assuming that they're not filtered. They're not summarized.
Yeah, think of me as like more on the core side of things, and maybe you're out at the edge. Okay.
Exactly.
Yeah.
I'm more of an edge. I'm more of like an access switch or at a remote site, and I'm that edge switch or edge router at that remote site. I'm receiving all of the hub information from Ethan. I'm getting all those routes that I care about, that I need. And he might be summarizing, he might not, right? But I will not advertise those routes out from me. Like if I have other additional neighbors, I won't advertise those routes because I'm the end, right? That's the idea, is I'm the end of the topology.
You're a stub. There's no way to get anywhere else by me. So, if I have a route and I don't have a feasible successor, and therefore I go into that query state, hey, a route was just withdrawn. Hey, Zig, do you have that route? If you're a stub, I'm never going to ask you that question.
Nope, exactly.
Because you've told me, based on a flag in your routing updates, I'm a stub router. Don't ask me these things. I don't know. And how that helps us with scaling, Zig. So here's a personal example. I had a network with about 9 core-facing routers and about 2,000 edge routers, all running EIGRP. We had that stuck in active problem where a route would be withdrawn from the edge, and a routing network that big WAN, it's going to happen all the time. And what would happen is one of the core routers would send out a query. The query would go out up to the edge, and that edge router would then ask another core router, and then back and forth and back and forth, just ping pong all over the place. And the network would be like, stuck in active, restart the EIGRP process, which would create a disturbance in the force. And
the dark side is strong.
The dark side was very strong and really pissed off my boss. And so our solution ultimately was, okay, all these edges, these 2,000 edge routers need to become stubs so that we don't have this stuck in active problem. Although that particular problem goes back some years, Zig, and if I remember right, there are now stuck in active timers that will prevent us from having that entire topological reset within the EIGRP domain. So you still get the scaling benefit, but you also don't have the stuck in active problem, at least not quite like it used to be, right?
Yeah, you definitely don't have it like you used to. The hardware has gotten better, right? There's more memory, more CPU, more bandwidth, and then the protocols have advanced or evolved is probably a better word, evolved. What I can say is that for those that are lab people like us, I would say we like to go in the lab, Ethan. Maybe we don't anymore, but I'll talk for you for a minute. Sure. I think we like to go to the lab and play around with routers and switches. And so for those that maybe they haven't seen a stuck in active situation, you can totally make this up in the lab with a couple devices. So if you have a physical lab, you have 3 devices, 3 routers or 3 switches that can run EIGRP. You can totally create this. If you don't have a physical lab and you have a virtual lab, this is a lot easier in the virtual lab anyway. If you're using CML2 or what else, Eve NG or GNS3, whatever emulation or simulation software that's out there, you can easily create this and see it in real time, right? And see what happens. Look at the timers. It's going to be really clear how this works and what happens, and then what you have to do to mitigate it. And honestly, like Ethan said, you have to clear the process. That's really the only way. And then, so you pretty much have to clear a process on that router, that EIGRP process. And that's a hard clear, right? That's going to take a little bit for that to come back up.
And what's happening here, I don't think we've said what's actually going on. Because the query process is not bounded, it's just going to ping pong around the topology, and every router that sends out a query is waiting for a response. So you end up with the EIGRP just sitting there like, I haven't heard back. I haven't heard back. I haven't heard back. And the more routers that are in the topology, you're compounding the problem as the query scope is the entire, if the query scope is the entire network and you've got hundreds or thousands of routers, you're, again, this is a scaling challenge. I was going to say a problem for EIGRP, but it's more of a, it's a design thing.
It's a
challenge isn't the right word either. It's not a problem.
Exactly.
It's just, you have to design with that issue in mind.
So we're harping on this stuck and active design situation. This is kind of like problem, right? If we want to call it a problem. And if we go back 15 years or 20 years, this was a problem all the time. And it's because EIGRP wasn't designed properly to mitigate it. Like people were just throwing EIGRP. It's simple, right? It's that simple solution. Throw EIGRP and walk away. But as these networks got bigger and bigger and bigger, they started having these stuck and active situations because they never actually designed EIGRP. So, in the short term, EIGRP is an easy solution to throw in a small environment. You're not going to have, unless something's totally wrong, you're not going to have a stuck and active problem or situation come up in a small topology. Yeah, but exactly. As you scale up, you have to make sure you keep that in mind, right? You got to design for that situation. You got to be mentally, your mindset has to be clear that, hey, this is a remote site. There's no additional routers. This is one device. Let's make it a stub router. Let's limit that query domain.
Yes,
now,
very much.
I'll add that there's functionalities that, like, let's say you do have that remote location and you do create that edge device and make that edge device EIGRP stub. There's ways that you can do like leak routes. You can leak routes. I don't know if you're going to, yeah. So I've had to use these in real situations.
You're talking about the scenario where you might actually want a couple of edge routers to be like a backdoor to get through where topologically that's okay. And in that case, you still want it to be stubs, but you might want to leak a few routes so that in a failure scenario, you could fail over to that link.
You got it. You got it 100%. I'll use the real world example, my home lab. So if I went down to my basement, you can't see it in my camera here because it's in my basement, but I run EIGRP at home because why not? It's my home lab. But some of the devices don't actually support a normal or full EIGRP instance process. They're limited based on licenses to only be able to do stub routing. So I'm actually doing leak route. I'm leaking routes between my one switch to another switch because it's only supporting stub routing. Now I could fix that, right? I could add a license and do full normal routing. I don't have a need to. I'm just doing a quick leak. I'm actually leaking the default route, to be clear. And I'm leaking that default route down to the follow-on switch. And then that switch knows how to get out now, right?
Dude, that is the simplest. That's beautiful because it's so simple. It's elegant.
That's what I'd recommend, right? Now, the other caveat to that, though, is that other router, you probably have routes on that other router, right? Somehow you have to show everyone else those routes, right? So what I usually do is on that stub router, I have to either redistribute those routes because I have to source them from that stub router. They have to be my routes. If I'm a stub router and I want to advertise my routes up to the next to Ethan again, right? To the core, to the hub, I have to source those routes. Now, if those routes are coming from that further back device, that further back or down device, he's sourcing those routes and he could share them with me. But because he sourced them, not me, I'm not going to share them because I'm stub. Unless I'm leaking them.
Unless you're leaking them. That's right. Yeah. And when you pop these, like if you're at the CLI and you pop the stub statement in there, you can say, there's a whole list of, I want to leak these kinds of things. This is what I want to announce from me, even as a stub router. And it's not overly complicated to get this done.
No, it's actually pretty simple. So it's not too hard. I mean, it's, you configure stub and then you got summary. So you can do all summary routes. It'll advertise all summary routes. You can do leak, which is just going to be a route map. So if you're familiar with route maps, you could do like prefix lists, whatever, real easy. Call out the subnets that or the networks you want to advertise, leak out. And like I said, I use the default route a lot. Like, honestly, like if I'm going to do something like one way, I just send a default route down. I don't like static. I'm not a big fan of doing statics if I don't have to. So I'd rather receive a default route dynamically with some sort of leaking versus doing a static default route on that edge, that last device, right?
So we've been talking about, we keep diving into specifics because we're nerds and we can't help ourselves.
Well, we love this. Again, we're defending EIGRP here, right? That's the
there's
whole point.
another
We're
zoom out
defending it. So
question I have for us. So going back to that greenfield scenario, let's not forget about technology, but let's look at business requirements and apply EIGRP to some business requirements, which I know from a CCDE perspective, you're comfortable doing this. This is the kind of the mindset that you live in, as far as I can tell from listening to your podcast. Are there other business requirements that you can think of that might drive you towards EIGRP instead of OSPF, perhaps?
yeah, so we've said a couple of them kind of roundabout, right? We haven't come out and said, hey, this is a good business requirement, so this is good, right? So I'll start from the bottom here, because I think this is one we've already kind of talked about. It's flexibility, right? Like you have the ability to kind of run your topology and you can summarize, like I said, right? You have the ability, that flexibility is key to summarize, and you can filter. You can easily filter. Now you can't easily filter an OSPF. So just keep that in mind. Go ahead, Ethan.
So from a business requirement, what you're saying is, here are some features that, depending on what the business is looking for, might become applicable. The flexibility, the fact that you can summarize wherever, which we brought up those points before, again, as engineers and nerds. But again, mapping those features back to whatever the business scenario is a doable thing.
Yeah. So like, let's actually do that. Let's use some examples to make it kind of clear, right? We'll bridge that gap. I like to call it, we're bridging the technology and the business side of things. I'm using one hand. I should have used two. So the business and technology, right? That's the whole point of what network design is. We got to bridge that gap. So here, for flexibility, for example, right? Like, maybe you're in a situation where your company, your organization, your business needs to add, 100 routers, 100 VPN routers into your topology. And if you have OSPF and you have a flat OSPF area 0, if you go to do that, now you're injecting how many, those 100 routers. And let's say all those routers have 4 routes on them, 4 networks that they own. I mean, that's 400, new LSAs or new networks that OSPF area 0 is going to have now. And furthermore, let's say that there's some constant churn on those devices. They're going up, they're going down, right? Every time one of those networks goes offline for whatever reason, it's sending LSA updates with different LSA types, but we're not going to get into the details on that. But like, just clear, like there's a lot of churn. There's a lot of reconvergence churn,
there's a lot of churn that every router in that OSPF domain is doing. Yeah.
Every router. Exactly.
Which to be fair, modern control plane CPUs, maybe not such a big deal, but the point still stands. There is churn and calculations going on.
Yeah, so I wouldn't say it's like a CPU. I wouldn't say it's a resource issue anymore. Like we have enough memory and CPU cycles on these devices where it's not necessarily a resource issue or a bandwidth issue either, right? It's going to be more about how fast are you reconverging now, right? Like how fast is that network going to be back online? Or maybe it's not, right? And then again, we're comparing it to OSPF specifically, but if you look at 2 different routers in that OSPF area 0 domain, and they're different locations within that one single area, they could have very different database tables because they haven't received the updates, right? They're trying to receive the updates and they haven't gotten them. They haven't processed them. And that's one of those situations where if your database tables, specifically for OSPF, are not in sync, then you're going to have a totally different routing topology. Like that's what the basis of routing is for OSPF. But back to flexibility, right? I can get in the weeds, obviously, Ethan. So back to flexibility, right? So OSPF in that situation may not be able to be as flexible to help the business scale. So think of the business as, hey, we need to add more remote sites because, hey, COVID, right? Hey, we're every house, every home office is now a remote site. Right. So let's think of that as let's say a company has 100 employees and every home office is now a remote site. They have their own device, whatever, and they have to now connect back in from a topology perspective. If you're running OSPF, that is not conducive to uptime, high availability because of the limitations within an area 0, flat area 0 design. EIGRP, on the other hand, flexible, right? We can easily throw that in there. It's not going to have any issues. Every router can be part of that process. And if we had to, we could limit the query domain with doing stub routers at everyone's house. Now, on the contrary side, if we're doing OSPF for some reason, we have to do OSPF. we could always do different area types, right? Like that is a value thing. We do different area types,
Yep.
and then have a concentrated location where those routes are coming in, but not being propagated further within OSPF, further areas, right?
You're saying like have an area 0 in the middle, kind of a hub and spoke, but an area 0 in the middle, some different area out there at the edge where the VPN routers are connecting in. So if there's some churn, it's really isolated to the area that's out there at the edge. The core OSPF doesn't, area 0, backbone area, doesn't see that churn.
Yeah, and it goes more into summarization though as well, like on an ASBR. So we didn't get into like router types, and again, this isn't supposed to be an OSPF show, right? But it's coming that way, Ethan. So, but the point I'm trying to make is that you have to design it and you have to do some summarization on your ASBRs, because those routers on the back end are going to have routes. Now, if you don't summarize, you're going to get summary addresses or summary ranges for every network that's behind that ASBR sent to area 0, to the area 0. So what is an easy solution is saying, hey, here's all those networks that are at those remote sites. Let's summarize them into one network, right? Yep. Let's make it easy. Let's make it simple, but we have to design it that way. We summarize it into one network, and now it's never getting changed. Because
if one of the networks in the summary falls out, it's fine. The summary statement remains the same. Yeah.
So you go from having possibly 400 plus LSA updates to every router in OSPF to now having no LSA updates because it's a summarization. The only time you'd have an LSA update is if every single network went offline within that summary, right? So you'd have that update. But that's designing OSPF. Now, on the flip side, EIGRP, you just kind of throw it out there, right? You kind of throw it out there. In that same situation, it's going to function. It's going to work. The scalability issues that you get with OSPF is going to hit like when you start getting thousands, I would say, that 1,000 number. And that's not a straight calculation. You know, that's not an always situation. So don't say, Zig told me that if I hit 1,000 routers, it's going to be a problem. That's not what I'm trying to say. It's situational, right? So that's a ballpark. It might be 900. It might be 500 in your situation. It might be 1,500. The point is that 100 routers are going to scale. Like it's going to scale pretty easily without any issues. So flexibility. That was a long way, Ethan. I'm sorry, buddy. That was a long tangent on flexibility and tying it to business.
You know, but there's an underlying principle here that I think is really important, Zig, that you've made. Understanding how OSPF functions in a given scenario versus how EIGRP functions in a scenario can define which routing protocol you prescribe to solve that business problem. And so if you're somewhat ignorant of what's really going on there, it makes it tough for you to make the right choice, and you can, in fact, especially at scale, make the wrong choice.
Oh, yes. And then you have a design failure. Right. And then you're going to be called back in to solve it, or I'm going to be called in to solve it. So it's like, sorry, had to throw that out there.
So flexibility, that's a big deal. Simplicity, we're getting into some more repeatable, more predictable designs that we can replicate that could be a little harder to do in OSPF depending.
Well, so simplicity, what I would say there, so it's simplicity KISS, right? Keep it simple, and it's keep it simple, stupid, right? So KISS. And I'm a big fan of simplicity, right? Keep it simple. Like, don't make it complex if you don't need to make it complex. So don't run multi-area OSPF if you don't need to.
Yeah.
If you EIGRP, you can throw it and walk away. So think of how long it takes to design something. Like, think of how long it takes to design an OSPF area types and whatnot. But then think of how long it takes you to design EIGRP and throwing it out there. In most cases, EIGRP is going to be quicker, easier, and now you can focus on those other business lines of effort that you need to focus on, that your business wants you to focus on. So I look at that as a requirement or a business, I guess, requirement. Simplicity, because it's not necessarily tied to a business like goal, but now you can focus your time on something else. You're not sitting there focusing on OSPF for a week. You know, you're focusing on EIGRP for a day or maybe 4 hours, and now you're done with that task, right? You've rolled out EIGRP, and now you can focus on that, that business initiative that's going to give your business more money versus, you playing around the OSPF for a week and a half or 2 weeks or whatever. So there's that one. And then unequal cost load balancing is another one, right? So if there's a requirement where we don't have equal cost links, meaning that they're not the same bandwidth, and we're not manually changing it or whatever, because natively both OSPF and EIGRP can do equal cost multipathing, right? They can do equal cost load balancing. but EIGRP can do unequal cost load balancing, and that's a variance configuration, right?
What are you
I know,
saying?
it's
I thought there
amazing.
could be only one.
So that is a good use case where, hey, let's use EIGRP.
And the big idea here is you got something with more bandwidth and something with less bandwidth, but you can still push traffic across both of them where you don't actually have to have there can be only one, or they must be equal and I will distribute equally across the equal paths. So that's kind of, and I think a lot of people maybe don't even know about that. In fact, I'd forgotten about unequal cost load balancing and I've used it in the past.
Yeah. It's awesome. I mean, it really is pretty cool. So, now you have to configure it and it's ratio based, right? So you have to understand that ratio and the mechanics under the hood. And we're not going to get into the weeds here on that, but it's all hash based. And so, if you could do 2-to-1, right? You could do, hey, this link is 100 meg, this link's 10 meg. I don't know if anyone has 10 meg links anymore. Maybe 100 meg and a gig is probably a better option, right? So you have a gig and 100 meg. Well, whatever ratio that fits for that. And I would say you have to monitor your bandwidth and monitor your links and then adjust accordingly. And it's the variance command within EIGRP. You can change the variance and tweak it however you want it to tweak it. But that's a use case I've seen a number of times in production networks. Less these days. I don't know when you did it, Ethan, but I see it less these days because most people have equal links.
Goes back a decade, I think, Sig.
Yeah, it's been a while, right?
It was a scenario of multiple WAN links is usually what it was that weren't all the exact same, but you didn't, awfully expensive bandwidth just sit there doing nothing if you can push some traffic across them.
And that's my basis, right? Why are you spending money on links and you're using it as an active standby or an active failover, right? Like that's even with spanning tree. That's why I don't like spanning tree. I know there's a purpose for it, but like I'm running dual links, so I want to use those links, right? So let me figure out a way to use those links effectively. In my situation is more like data center with DCI, data center interconnects, where one link's like 10 gigs and one link's like 1 gig. Right? I want to use both links. So let me use both links. And that's a good use case to use those links with EIGRP. In OSPF, you can't, right? That's just not a possibility. So you're limited to an active link and kind of a standby link. And then the last one I would say is, hey, my staff already knows the technology. They've already had experience with EIGRP. So let's keep it with what they know, right? Unless there's another requirement, another constraint or outcome a business is looking to achieve that would would make sense to pick something else and force your staff to learn it. Like, hey, you're going to learn OSPF right now. Yeah, no. I do go with EIGRP, right? It's not, just, it. You're familiar with it. You're confident in it. Let's go run it.
If there's not some compelling technical reason where you really need to go with this other solution, why not go with what you already know? Exactly. Is the point you're making. Yeah.
Exactly.
Okay.
And I'm going to caveat that, or not caveat that, but I'm going to add some additional meat to that, I guess. Caveat's the wrong word. That's the same thing for like the CCD exam, right? So if anyone's going after the CCDE exam, the Cisco Certified Design Expert exam, that certification, like as you go through those scenarios, that's the same thing. If your staff knows the technology at hand, that's a good benefit, right? That's a good outcome. You don't have to teach the staff new stuff. So when you're comparing options like EIGRP versus OSPF, like we're talking about today, if my staff knows EIGRP and they don't know OSPF and there's no other governing requirements to choose OSPF, then I would choose EIGRP.
Yep. Okay. Fair enough. All right, Zig, we're going to go back in the weeds. Let's pretend we haven't been in the weeds pretty much since minute 2.
We haven't gotten that low. We haven't been in zeros and ones yet. We haven't talked about K values yet.
Like, we're going to talk about K values right now. Okay, folks. Zig being a CCD and doing EIGRP networks fairly regularly, I wanted to pick his brain on some stuff relating to EIGRP design and his design recommendations based on what he's seen in production and so on. And I have my own opinions too, but Zig, let's start with K values. Now, for those of you who don't have a clue what K values are in relation to EIGRP, the EIGRP has a formula for how it calculates the cost of a path effectively. And is it 5 K values?
There's 5. Yeah, there's
5. Okay. And if you look at the formula, it's this complex looking math thing that looks like you need a PhD to understand. It's actually not that bad if you sit and just describe it. But the default way that formula is calculated, 3 of the, correct me if I'm wrong here, Zig, but 3 of the 5 K values are zeroed out. They don't actually impact the bottom line. And you're left with bandwidth and delay. Is that right?
Yes, I'm pretty sure that's accurate. I'd have
Those
to
are
go
the
look it
two
up,
K values
but
that are
those are the
that an
two K
EIGRP
values
route
that matter,
is
right?
calculated on. Yeah.
Based on the initial calculations is delay, bandwidth and delay. And I believe they're the first two. I forgot the order. I won't lie, right? I always use a question mark.
It kind of doesn't matter, but because the temptation is for a nerd, oh, I can screw with the K values and tweak them. I'm going to tweak them because they're tweakable. Roar,
It's a nerd knob, right? It's another nerd knob that someone says, hey, I'm going to tweak this nerd knob.
But in reality, we actually never see that. I've never worked on an EIGRP network where K values are anything other than defaults, meaning bandwidth and delay are what matters and the rest of them don't.
I've had it twice in 20 years. So 20 plus years, I've seen it twice in production networks, and they were valid use cases. They were valid use cases, but they were one-offs. They weren't like a common use case, right? So it's not a normal thing. And I actually have seen it a ton of times in production networks where it was stupid. Like I can't tell you enough. Like remember KISS? We talked about that like 10 minutes ago. KISS, keep it simple, stupid. Don't modify the K values. Like seriously, just there's no need. Like these days, there's just no need to modify the K values. That's my
and I completely agree with that. The only place where I was kind of hoping it would work is I think one of the K values is load, where in the theory would be if there's a lot of load on a link, you could maybe dynamically shift routing around. I don't think it actually works that way, ultimately. And you'd have so much churn in your network anyway if you actually, if it did actually work that way.
The implications
that's the kind of thing that sounds like a good idea, but.
Well, it's like, I don't know. I was trying to think of an analogy where it's a good idea to do this, but I never do. Working out, right? It's a good idea to work out every day, but do I really do it? No. No, but here, so like to that point, I think if under the hood of, I think that any protocol could intelligently measure the load and in real time dynamically change where things are going, that'd be great. But that's where we're getting with like software-defined solutions, right? That's where Sd-Wan and, software-defined campus and, whatever buzzword we want to throw in there, intent-based networking, we'll just throw it in there. Zero trust architecture. We'll just throw it all in there right now. But the point is that like, that's where things are today, like with those software-defined solutions. I don't see these routing protocols being modified to do it to the scale that these software-defined solutions are going to be doing it.
No, I agree with you. Where you see that fancy stuff, service providers, of course, having had that specific use case for a very long time and have had all kinds of ways to do that. They'll manually program the forwarding table, not manual like with a human, but some software-defined controller with a policy policy engine that's been set up accordingly is going to move traffic around to their different, very expensive links based on load, time of day, these kind of things, not relying on a routing protocol like EIGRP to try to figure that out for them on the fly. It's going to be some centralized controller. Yeah,
it's going to be all API based. There, we got automation in here too now. Look at that.
Oh, yes. Awesome. Yes, automation. Buzzword. Ding. If you're playing buzzword bingo, make sure you check your box. All right, so K values, leave them at default. Don't mess with them. Very good. Yeah. Okay. Link numbering, IPv4, v6 link numbering. How do you I'm talking about the link in between a pair of EIGRP neighbors. Do you number them? Do you leave them unnumbered? What's your style, Zig?
So I've always wanted to number them. That's just a personal opinion. I think we have to go back, right? Everything's done for a reason. So we have to go back in time. Why was unnumbering configured? And the thing I remember when I was first starting out is that IP unnumbered was brought in because we couldn't subnet, right? So for those that don't remember, if you go back in time, VLSM, variable length subnet masks, never existed, right? So think of the day when we talked about RIP. We already talked about RIP. RIP didn't support VLSM, and neither did IGRP. IGRP was a routing protocol before EIGRP. So those that don't know that, that's what that is.
You're going way back in time, buddy. But
yeah. So, but the implication here is that you have to understand why something was created to then know like what was the purpose. Okay, we don't need to do it anymore. That's really what it comes down to. So this was back when you couldn't subnet. You couldn't get those /30s or those /31s for IPv4. So if you were going to create a link network, it'd be a /24. You couldn't subnet any further than that. So you'd be using an entire /24 dedicated to each individual link if you were doing it that way. So to mitigate that, they created IP unnumbered, where it would use a loopback address. It actually would lose any pre-configured, not pre-configured. You could specify any interface that already had an IP address on it to use as that unnumbered address. But the recommendation is to use a loopback address so it never goes down. So you'd create like loopback 0, give your IP address on it, and then all your physical links would be configured IP unnumbered, and you'd source or you'd call out that loopback 0. And really what that would do is now all of those links would actually form adjacencies with that same IP address, right? Like it's just a different MAC address, right? But it's forming it because it's point to point, and it'll see it up, and it'll come right up. And it's a good mechanism to save IP addresses. That was the original use case. But today we can subnet. And there's a lot of underlying issues, in my opinion, with IP unnumbered. It does add some complexity, right? When you're troubleshooting a network, you're not going to know the link IP addresses, right? You're going to have to figure out where things are going and who formed that adjacency. So I'm very, my opinion, I'm opinionated on this, is to use IPv4 addresses on your link addresses, not IP unnumbered. And there's another debate. Do you use a /30 or /31? So Ethan, what do you do? Do you use a /30 or do you use a /31?
/30 keeps it simple. It just keeps it a little bit simpler. Yes, it burns more addresses for sure, but if you're in that scenario where you have to conserve addresses and you want to use a /31, fine. But /30 is a little simpler for me, I guess. Do you have a take on it?
Yeah, I do /30s. I think I've never done /31s, to be fully transparent. Never touched the /31. Never designed a solution that used /31s, if that's even helpful. But I think there's some implications of where that might be helpful to use a /31. I would say large scale kind of service provider networks, where they could be limited on addressing, right? I mean, even the RFC 1918, your private addressing space, you could be limited because you have so many different customers and subnets being leveraged. So I could see it being used there. And then there's another thought that it could be some increased security, but I don't know how accurate that really is. I mean, it's less IP addresses being leveraged, less networks, or more networks, but there's segregation, right? It's a broadcast domain. So
now, if you're listening to Zig and I talk about /30s, /31s, and you're not getting what the issue here is, if you use a /30, that's a subnet mask of 255, 255, 255, 252. That is a block of 4 addresses. Then you're burning the top address and the bottom address. The top one's a broadcast, and the top one, they're both. You're burning
so the top
both.
One's the network address, and the bottom one's the broadcast.
And the bottom one's the broadcast.
Just to help you there, Ethan.
And you only shut
Sorry,
up.
Sorry, buddy. Yeah, dude.
And you only get to use the 2 in the middle, so it's a bit wasteful of the address space. And if I forget what the command is, there's some command that would allow you to use a /31, which means kind of like pretend there is no network address and broadcast address. We're just going to use every single address for the links. But again, the scenarios where you'd really need that, you'd have to be a really large org. You burn through basically RFC 1918, and you're just struggling to conserve addresses on your links. That's a massive network. Other than that, do you really need to do that? It seems like overkill to me for most scenarios. Well, so what about IPv6 link numbering, Zig?
Yeah, so it also is supported. There's a feature there to do IPv6 unnumbered. And the same debates there. Do you use a /126 or a /127? There's that as well. I have never seen. I can't say that. I actually have one customer today that's using IP unnumbered for both IPv4 and IPv6, but there is no valid business justification behind that. Like there was no, this was just done just because they wanted to run dual stack and they wanted to conserve their IP addresses for some reason. I don't know. There was no valid reason. And actually they have a lot of issues with it today. That's a VXLAN environment, so it's a little bit more advanced. It's not like a normal routing environment. And so they're just having a whole bunch of issues with VXLAN not functioning and IP unnumbered being leveraged everywhere for both protocols, IPv4 and IPv6.
I'll tell you, for V6, I don't even think the debate is /126, /127 or unnumbered. I don't even think that's the debate. I think the debate is /64 versus like a /126 or 127, something like that. So like the guys over at IPv6 Buzz being another podcast in the Packet Pushers network. If you're interested in that, packetpushers.net/subscribe, and the information about IPv6 Buzz is there. They nerd out on V6 every 2 weeks, I believe. Well, Tom Coffeen, who's one of the co-hosts there, he wrote a book on V6 numbering. It's on the shelf right behind my head here. I believe, I hope I don't have this wrong. Tom, if you listen to this and I have it wrong, you can, yell at me on Twitter or something. But
Yell at 'em.
slash
Do it.
64 is they're assigning slash 64s to links. The idea being, if you do the math on how much address space you have in a block of like a slash 48 or, slash 40, whatever it is, you can't exhaust, even if you're wasting an enormous amount of address, like you would be using a slash 64 and v6 address space, and it's fine. So Zig, I don't know if you've run into this in real life or not.
Yeah, I have. So funny that you mentioned that. So, a lot of people want to use slash 64. I actually have a Cisco Live lab that I do every so often, an IPv6 lab. And if it's a paid for session, it's not going this year because we're all digital, but it'll go when we go back on site. But so it's a paid for lab, and there's actually I do both. I do a slash 64 and I show the implications of that, and then I show a slash 127. Because that's what I use, just to be clear. If I'm going to use it, I don't use a slash 126. I use a slash 127. And there's some benefits, right? You are conserving those addresses. So if you're not given a very large range from your providers, and think of if someone's governing your IPv6 range, right? You don't own everything. Someone else owns it, and they're giving you a chunk. I could see that being a good use case to summarize it effectively. But outside of something like that, if you own your own range, I mean, you're going to have a whole bunch of addresses. So I think it's more of a, what do you want to do? What do you prefer, right? Do you want to see slash 64s everywhere, or do you want to see a slash 127s everywhere?
Oh, and I know the instinct of all of us that are engineers are just conserve, because we grew up in the IPv4 era. It's hard to shift to that plenty mindset. I have plenty of addresses, more than I could ever use. At the moment, based on just having done the math, I feel okay with slash 64s, but it still freaks me out. It's just,
it's a lot, what I mean?
Though. It still freaks me out.
I know. And you're doing it on your link addresses, right? Like your link addresses.
I know.
Like, it's crazy.
It feels wrong, but it's like, but I know it's going to be okay, but I still struggle with it.
It's almost like you have to change your mindset, right? You have to like embrace it and be like, okay, I'm okay. And you do slash 64 and you walk away. So there is a design use case, corner case for this, just for IP unnumbered specifically, just to let you know. So overlapping subnets. So think of, you have overlapping subnets and you don't want to use some sort of natting to mitigate that. Like think of a driver where you can't change the subnets and they're overlapping. Well, you could do IP unnumbered to kind of get around that. That is a good use case solution. It's like kind of out there. It's kind of out of the box. Yeah. It's not what you would normally think.
Yeah. All right. More design stuff I want to ask you about relating to convergence times and EIGRP, Zig.
Yeah.
So let's talk about EIGRP convergence in its default state. What is that? How much time does that typically take? Maybe we want to bring up successors and feasible successors again. Talk us through it.
Yeah. So, I mean, I think most people are never going to actually see how long it takes. It's going to be so instantaneous to us, right? The timing for it, if you have a feasible successor. So remember, if you have a successor, you have a route, right? You have a route that EIGRP is chosen as your main route to go to. And there's a qualified feasible successor to that route, which means there's a backup route. All right. And that is already calculated and it's already in the EIGRP topology table. So think of the topology table as the EIGRP database. It's the brain of EIGRP. It's telling EIGRP, hey, I have a backup route for this. I don't have a backup route for that. So if there's a backup route, that feasible successor, it is so fast. It is like, I mean, I put on here a 1/10 of a second. And that's for 1,000 routes. That's not for one route. That's up to 1,000 routes on that device. So in a 1/10 of a second, it's going to reconverge and you're going to be able to pass traffic.
By reconverge, we mean specifically, it's going to move from RIB to FIB. It's going to move from the routing information in a backup state and be installed in the forwarding table of that router. And you're actively making packet forwarding decisions based on that newly installed route that came from that feasible successor.
You got it. Yep. And it's, I mean, honestly, the traffic is going to seem instantaneous, right? If you were pinging a network from where you are to where it's going, I mean, you're going to maybe see a blip, like one ping drop, right? If that. This is so fast that you're not going to really see it. Now that's one case, right? That's assuming you have a feasible successor, which again, they're calculated by default. Now, in the case where you don't have a feasible successor, this is going to be a little longer. It's going to take about half a second. right? So just keep that in mind that, I mean, you're going to see that, right? That's going to be noticeable for you, your users. They're going to notice that there's a delay, right? There's a short delay, half a second, and that's going to compound as you go from router to router. But again, that's threshold's 1,000 routes, right? That's the 1,000 routes to take about half a second to reconverge. And it'll be larger if you have larger routes, and like if you have 10,000, 20,000 routes, right?
Now, this gets back into the whole query thing that we were talking about earlier when we were explaining how stub networking or stub routers help us to scale our EIGRP networks. We are talking about, in this case, if I don't have a feasible successor, I have to go through that query process. Hey, I just lost this route. I don't have a feasible successor. Do you know how to get there, other EIGRP neighbor? And it asks and it asks and it asks everybody else that's around him. Then 1,000 routes, half a second for that query process to complete on average, kind of rule of thumb.
Yeah, that's an average, right? These aren't hard set numbers. That's an average. And it's a process, right? So again, it's flexible based on how big and how the scale of the environment you have. That makes sense. Now, I think you want to get into, when do we tweak these timers, right? So this is the default settings, right? But when do we tweak these timers?
So let me throw at you what I think of as a reason why we maybe would want to tweak timers. And that one specific scenario, at least from a technical perspective, are micro loops where there is a sub-second amount of time where you're not forwarding to the feasible successor, or you're not forwarding to wherever the route converges, because maybe you didn't have a feasible successor, and that's a micro loop. You're forwarding and maybe you're sending it out the wrong interface because we haven't converged yet, or it gets black holed. It can't go anywhere. This sort of a scenario. And in certain environments, maybe that's not acceptable. I used to work in a payment card environment, and I had a few customers that were going to call if they dropped even a single transaction because they were monitoring that closely. And so an unstable routing domain, even if it was sub-second, could potentially be noticed by that customer, and we wanted to avoid those things. So maybe we would tweak timers to force EIGRP to converge even faster. Although I guess this gets into things like neighbor adjacencies and stuff like that, what we're really talking about, those timers going back and forth as EIGRP neighbors come up and then stay in touch with each other. How does EIGRP know that he's lost a neighbor and stuff like that to kind of hasten that process?
Yeah, these are specific,
because you've got this weird, it's real specific in my mind.
Yeah, I think you got to break it down, right? So fast convergence can be a number of things. So like the feasible successor option there, that's not necessarily reconverging or reneighboring or detecting a failure, or a neighbor failure, right? Or a link failure or whatever like that. This is specific to, hey, we lost this network. We lost this network in our table, and we have a feasible path. We have a backup path. Or if we don't, and how fast can we install that backup path or find a new one so that we can pass traffic to that network? So there's that option, right? But then there's also like, how do we detect that our neighbor is down? And honestly, if it's a point-to-point link, that's going to be pretty quick, right? It's a point-to-point link. EIGRP is going to hit that line notification, that physical interface notification. It's going to be, hey, the interface went down. Okay, our neighbor's down. Now, there's a case for that where it's not going to actually, that line, that physical connection isn't going to go down, but the neighbor's down, right?
There is a lot of gray failure situations there. Yeah.
And that's where I would run BFD, something like BFD, right? That's a use case for, and I forget what BFD stands for off the top of my head.
Bidirectional forwarding detection.
Yeah, there you go. I knew you were going to back me up there. Yes. So I would use BFD there because let's do a topology. You have two routers and they're both connected to a switch, right? And that switch doesn't route. And they're forming an EIGRP adjacency between the two routers, and that switch is just a layer 2 switch. Well, if a link between the switch and one of those routers goes down, it's going to take some time for that to propagate back to that other router. There's hello timers and there's neighborship timers. There's a whole bunch of timers.
Okay, the point you're making here, the switch in the middle means I've got two Ethernet links as opposed to the routers being directly connected via their Ethernet interfaces. So if one goes down, the other router that's still up says, I've still got an Ethernet link. Everything's great, right? Hello. And eventually it fails. Yeah.
And you're waving, right? And you're waving forever and you're waiting for that response and you never get it, right?
And BFD to the rescue.
In BFD to the rescue. BFD is that you know, that rescuer that's going to come in and say, hey, we can't connect to the peer. It's down. So let's bring that adjacency down, right? And not send hellos and wait.
So BFD is not part of EIGRP. It is a separate process that sits. I like to think of it as sitting kind of under the routing protocol, because it's the BFD process runs between the two devices and runs very quickly. There's a lot of traffic, not a lot of traffic volume wise, but there's a constant back and forth between BFDs. This is how I like to think of it. If I'm getting details wrong, just tell me to shut up, Zig. But
you're fine.
But when a failure is detected, like in this example we've been giving, two routers connected together with a switch in the middle, and one of those links fails, BFD will very quickly detect, I can't talk to my BFD neighbor anymore. I'm going to tell EIGRP about this. Hey, EIGRP, there's a failure to this other router. You can go ahead and kill that neighbor because he ain't there anymore.
Exactly. I mean, that's the best way to say it right now. BFD is another protocol. It ties into a whole bunch of protocols. So not just EIGRP, but EIGRP is the use case we're leveraging it for. But if you have a fast first hop redundancy protocol like HSRP or VRRP, whatever you're using, it can work there too. It can help you get you that quick fail back or fail down situation, right? And that's what I would use BFD again to help you there. Now the question comes to what would I tweak, right? Because this is the other option, right? So there was reconvergence of a specific route, right? With backup routes or not backup routes. There was my neighbors aren't up, but I don't know, right? So BFD, I think those are the two that I've already talked about. Then the third one is, do we just tweak the timers, right? Why do we ever need to tweak the timers? And me personally, I really have no business justification on tweaking EIGRP timers. My opinion would be if I'm going to need to tweak EIGRP timers, I'm probably going to leverage some other protocols to help me with sub-second or nanosecond failover, or even like in a service provider world where we're running MPLS with traffic engineering tunnels, in which case I wouldn't be running EIGRP, right? I'd be running OSPF for ISIS because I'd be doing something a little different. My purpose would be different.
I don't like tweaking timers either. You have to get the timers right on both sides. It's just another opportunity to screw up.
Exactly.
It's
and if you tweak those timers, it's not just screwing up. If you tweak them too far, you could actually break that device. You don't even realize the implications to the CPU and the memory, and the churn on that physical device.
Yep. You are asking more of the device to, if you tune those timers too aggressively.
Exactly.
Yeah, and that in and of itself can cause.
And I've actually seen that in production. I've seen devices go offline because of that. You have to go and unplug it, plug it back in, and rebuild it up.
We mentioned ECMP earlier on the podcast, Zig. Any tips and tricks relating to equal cost multipath routing with EIGRP?
Yeah, I mean, you leverage it like it's awesome, but sorry, had to. There's some not limitations, but scaling, right? So I think there's a scale today of 4 at a time, but it's dependent on hardware, right? So I think there are some new devices today that can support up to 8. That's to 8 concurrent links where you're in neighborships, not just links, but neighborships. So it doesn't have to be links. It could be just neighbors. You could be running 8 neighborships to the same device over the same link, I guess. I don't know why you would do that per se, but you could do that. For the links themselves, if you had 8 links, you could do that on certain hardware, right? Now you have to set that in the configuration from 4 to 8. I don't know what the benefit, I don't know what a business outcome would be for that though. I've always been the type of person where if I'm going to have redundancy, I'm going to have 2, right? 2 of everything. Unless we can't do it for some reason. There's a requirement where we don't need it or we can't do it, but 2 for everything. And in certain circumstances, I'm going to do 4. But more than 4, it has this diminishing returns on the value add, right? So if I have 5 links, what am I getting? If I have 8 links, what am I getting, right? Now I have a port channel or I have redundant routing links, or at some point there's a threshold where you're hitting and it's not really valuable, right? There's more complexity and there's not a lot of benefit.
So you said port channel, which does bring up a design opinion I'd love to get from you. When we're talking about ECMP and EIGRP, we're talking about parallel layer 3 links that we can forward across. All right. Well, a different way to do this that looks kind of similar on paper, I have a port channel that I've built at layer 2. Let's say it's a layer 2 Ether channel, or I guess it could be a layer 3 ether channel. Either
Mm-hmm.
way,
Good.
there's a bunch of different ways you could configure this. Would you do port channels and do your, it's not really ECMP at that point. It's you're asking the ether channel to do the load balancing. EIGRP thinks it has a single link that it's forwarding across. It just happens to be a port channel bundle. Do you have a preference there?
So I would prefer to route when I have no other requirement. Like I'd prefer to route versus, so that's the first thing. I'd prefer to do layer 3 links. If I have a requirement where I have to span layer 2, I'll span layer 2. So that's the first thing. So that discussion between layer 2, layer 3 port channels.
I agree.
Now for how many, right? Like what I think it's situationally dependent on the environment. I would always break things up into 2s as a default answer. I'm not a fan of single points of failure. High availability, and I've been saying this for a while, high availability and redundancy and reliability and resiliency, all those buzzwords for network design principles, let's say, there's principles there. They're all unstated requirements. They're all things that businesses need, and they don't even say it anymore. It's really like the network has become the plumbing, right? That they become the water or electricity network. It's a utility now. And everyone requires it to work, right? If it doesn't work, well, someone's going to pay, right? I'm going to come over there and I'm going to beat you. It's not working. But so the point I'm trying to make is that I would make that assumption that it's a requirement. You have to have 2 of everything. Where it's an easy way to do it. It's not making a large, complex solution, and it makes sense. And at that point, once you have 2 of everything, then if you need more, you have to justify that, right? If I have to have 4 links or then why? What am I trying to accomplish there? Now, in your situation there, right? So I would not do a bundle of 4 links in a one single layer 3 port channel. I wouldn't do that. I would probably split that up into 2 links and do 2 layer 3 port channels across 4 links, right? So 4 physical cables. I would take 2 of them and say, hey, you guys are going to be in a port channel, and it's a layer 3 port channel. And then we're going to create that neighborship. I'm going to take the other 2 and do the exact same thing. And then if I was going to be really smart about it, I would track where I'm physically connecting those links and make sure they're going to different line cards on the devices.
Yep.
So if I had a line card failure or a soup failure, hey, we're good, right? Because that's the whole point here. We're trying to,
or at least a different
ASICs
ASICs on the front panel ports if you've only got one line card you can work with, or one switch you can work with. Yeah,
different ASIC group, right? Yeah, exactly. You got it. But that's design, right? That's design in a nutshell right there.
Yep. Not that every switch even gives you the ability to do that, but when you can. Oh, Zig, we're 70 plus minutes into this recording. We have so much more that we could talk about, but let's cherry pick on some hot topics here. Let's talk about EIGRP in Sd-Wan environments. So Sd-Wan is a big topic on the Packet Pushers podcast. We talk about it a lot, seeing massive adoption in the industry because it's pretty awesome. It really makes a lot of things better for a lot of folks in their WAN builds. Does EIGRP fit into Sd-Wan in some way? What are your thoughts here?
I mean, I think it's still there, right? Like it's not like it's going away. You still need an underlying topology, underlay topology routing, your underlay network, whatever terminology that leverages your software-defined WAN solution, being vendor agnostic, whatever terminology it uses for the underlay. You still need fast IP connectivity in the underlay. Right? Any of these software-defined overlay solutions, you need fast IP connectivity in the underlay. So, what's the solution there? If you're already running EIGRP today, you can continue to run EIGRP today. If you're running OSPF today, you can continue to run OSPF today. Without vendor-specific requirements, right? There's vendor-specific gotchas and requirements.
Of course. Yep.
So I don't want to say that's a blanket, hey, you can run OSPF today in whatever solution. You probably can't because there's vendor-specific requirements, constraints. But the point I'm trying to make is that it's still viable. You can still leverage it. You can still use it. A lot of the underlying things, it's a design situation, right? It's a design question. You have an underlay network and you have this SD-WAN overlay. So what is your underlay network truly doing? Are there services in your underlay network that your overlay network needs to access? A perfect example might be your overlay SD-WAN solution is going over MPLS links, and maybe you have a voice circuit or voice, you have SIP trunks. I'm going voice, right? So you have SIP trunks that you're leveraging from that same MPLS provider. Well, those are not going to inherently be in your overlay, right? They're going to be in that underlay because they're coming from your provider, and you're going to have to inject them into your overlay. Does that
Okay.
make sense?
Yep. Because you need to pump the voice traffic from like a remote office, let's say, across the SD-WAN and into that SIP trunk. And so for it to get there, it's got to go from the overlay into the underlay in this routing scenario.
You got it. You got it.
Yep.
Right.
Okay.
And so I would blanket this. That's an example, right? That's an example where you need something in the overlay and you need it to be in you need something that's in the underlay to be in that overlay. Now, if you don't have that requirement, then it really doesn't matter what you're running in your underlay, as long as it's fast IP connectivity, in my opinion. You're going to, in some cases, you need to support multicast, because some of these overlay solutions require that the underlay is running some sort of multicast, like source specific multicast SSM. And so you have to pre-configure that, right? So not that a routing protocol is it's not like the routing protocol is going to say you can't run multicast, right? But it's more of like, hey, you have to be able to run multicast in your underlay. It goes back to fast equal cost path IP connectivity. And I would say in the underlay, you want as fast as possible between your edges and your providers, because that's where you're going to go. You have no control over your providers. If it's internet or if it's MPLS, you don't have control over their network. So you want as fast from your devices to your providers and then across those clouds.
Well, okay, so speaking to that scenario, we don't actually have a contiguous EIGRP underlay between the different networks that we're interconnecting. The SD-WAN, again, is an overlay, but it's actually like the bridge between all of these different networks that we're connecting. So in that scenario, we've got these edges meeting. We've got an SD-WAN edge meeting with an EIGRP edge, let's say, in a headquarters location. Do you have any tips or comments on what that looks like? We're redistributing routes within our SD-WAN into EIGRP and vice versa?
Yeah. So I think the implication here is that you have to justify the use case. Do you need these routes or not, right? Do you need these SD-WAN routes in your underlay, or do you need these underlay routes in your overlay? But I think there's a design difference between how we legacy connected our WAN providers into our network. So when we did this before SD-WAN, we had our routing adjacencies. Let's say it's EIGRP, and we connected to whatever the provider was giving us, right? It could be OSPF, it could be BGP, it could be a number of things. Now we technically don't have to share routes like that, right? In certain circumstances, we don't actually have to share our internal routes to our provider anymore. We have to neighbor up, right? We have to get our SD-WAN connections to connect. So think of your two remote sites. You have a remote site here and you have a hub or a data center, right? Those routers, those SD-WAN routers have to connect, right? But outside of that, the MPLS provider or the internet provider, whatever it is, has no need to know what your underlying network is.
It's seeing tunnel packets going by. It has no idea what's in there.
Exactly, right? And this is kind of like MPLS, right? This is kind of like how MPLS is, where you don't need to share your link addresses anymore. You just share the loopback addresses and you neighbor everything up. Same concept. So you can simplify things that way. What I would be very careful with, though, is your overlay requires to form your overlay. Your underlay has to have the IPs between the two of them, right? They have to know how to get from point A to point B. If you learn your underlay IPs in your overlay, you're going to have this kind of flapping. Think of back in the day where you ran GRA tunnels, right? And you did a GRA tunnel from point A to point B. And you're like, hey, why is my GRA tunnel flapping? I'm trying to do an EIGRP neighborship across this tunnel. And it's going up and down, right? Up and down, up and down. It's because you're learning your underlay networks in your overlay, and then it's bringing down the overlay neighborship because it's learning the network again. So that's just a gotcha, right? You just got to be careful of that. So when you're doing anything like that with redistribution, because that's what you'd have to do, redistribution, you need a filter, right? You need to properly filter those routes and make sure you understand what's happening.
And you said something really key at the top of this segment, which was, ask yourself the question, do I need these routes to appear in the overlay or the underlay? And if so, why? And then make sure that they're learned the right way. Don't assume I have to do full mutual redistribution between this section of the network and the overlay and the SD-WAN. And I of course I do, right? Maybe, but maybe not. And so therefore think very carefully about what you need learned. And then, as you said, Zig, just like with any redistribution scheme, you're carefully going to have to filter between those routing
It's
domains.
so critical. It really is. I mean, you'll see it real quick when you make something wrong, because it's your links are just going to keep going up and down, up and down, up and down. And you're just going to be like, why is this happening?
What is this happening?
Why is this happening to me?
That's so sad.
To me. So that's my rule of thumb. Especially when you're doing bi-directional redistribution in multiple places. I mean, because again, in most cases, I'd probably doing that requirement in my core, my data center spaces, right? I'd be doing some sort of redistribution in data center. If it was underlay, need to go to overlay, need to go to underlay. That's where I would do it. But if you have a requirement where you need to do it at your edges as well, your remote sites, well, now you have to be super careful, right? Because you're doing it twice. You're doing it in your data centers and at your edge locations. You could have you could create a loop, right? You could create a very large loop, and it'd be hard to tell hard to find.
Okay, SD-WAN certainly a hot topic these days. Let's talk about automation then, because we got to hit all the buzzwords.
All the buzzwords, right?
Well, not that this needs to be a long part of the conversation, but is automating EIGRP configuration a thing that you've run into? I don't know why it wouldn't be, but throw it out there.
Yeah. So I mean, I think we automate everything, right? I think let's forget about APIs and automation tools for a minute. I think us as network engineers and network designers and network architects, we automate everything. We try to we're lazy. That's my reason. I'm lazy and I don't want to do all the work. So I'm going to automate it. So the simplest way of automating these things is we create templates, right? We created our configuration template. I think, Ethan, you and I talked about this last time at length, or maybe on my show you were on, I think, where we have these templates and they've been there for 15 years, right? And we have information in there that explains what each command is in like a comment, so we understand what the command is. We don't have to go look it up again. We've already learned it, but we haven't used it all in 5 years or 3 years or whatever time frame. But that template is automation. That template, all we do is copy, cut, or copy paste, and we're good, or modify it. We tweak it a little bit. So I think we just take that automation process and we leverage the same process with APIs and with controllers, because we're just automating anyway. We're just the manual process of us changing variables, manually changing those placeholders, and then applying the config. Well, let's change those placeholders in the controller, or let's let the controller change the placeholders. It's the same thing, right? It's the same end goal, same end result.
It is a fundamental network automation principle. You got to understand what you're automating before you can automate it. So that's really what you're saying here. You got to know EIGRP, and then just like anything else in network automation, it is a candidate to be automated.
Exactly. And I would go, if you start doing this, right, I'm talking about automating templates, right? And you're going to place them on a new device or changing your configuration. You're going to create a template, paste it on, right? If you start using automation, you need to understand the end state, right? Like you need to understand that, hey, this is where I am and this is where I'm going to, and this is what I should expect to see. What's good behavior and what's bad behavior? Because your automation system is just a tool, right? That's all it is. And it doesn't think like we think. It's helpful and there's some logic there, but it doesn't know the protocols and what you're trying to achieve intuitively. You're telling it, I want to do this. And if what you want to do is wrong, it's going to be wrong, right? That automation is just a tool. It's going to do what you want it to do.
It will happily automate your failure. Yes,
exactly. So, I mean, automation is great. I love it. And I'm on board. I may not be fully up on the DevNet certs yet and the other automation stuff out there. I have other things on my plate, but definitely embrace automation for sure. And I think you can use it with everything, not just EIGRP.
Well, Zig, this has been dude, I love conversations like this. This is outstanding. And you just share and share and share what's on your mind with the community. Just thank you, man. Thank you for what you do. You have a lot out there, not just on shows like this, but you got your own network of content. Just lay it on us, man. Tell us how we can get more Zig.
Yeah, Ethan, I appreciate it, man, as always. So I'll be as quick as I can, right? I think we're at like the 2-hour mark, right? Or something like that.
Almost an hour and a half. Almost
an hour and a half. Sorry, my math is wrong. Bad math. I'm not a math major, I promise. Yeah, so I run a network design podcast, a network design platform, let's say. Zigbits.tech is the blog and the show notes for all the podcasts. You can go to the main podcast page. It's zigbits.tech/ZNDP. That's Z as in zebra, NDP. It's a play in words, right? It's me being nerdy. Zigbits is Zig, right? And bits, tons of bits and bytes. And I think Ethan likes the zigabytes are faster than gigabytes, right? So
I am a subscriber to that podcast, Sig. I listen to it. It's great stuff. Yeah.
So I transitioned over the years. It used to be like a bi-weekly podcast. It's turned into a weekly podcast, and we do network design fundamentals, principles, techniques, frameworks. I mean, it's real world too. We do real world use cases, design use cases, automation use cases. And I get people like Ethan, industry experts on the show. Yeah. We talk about design and design situations. And the whole point is to provide you context and to really teach you network design. I think there's a gap. And I'm trying to fill this gap that we don't learn network design early enough in our careers. So
no, we learn how to turn the knobs before we learn why we should turn the knobs.
We can learn how to configure on the command line, and we type away and we're like, hey, I did it. I configured Eigrp, because that's what we're talking about, right? But it's not designed effectively or correctly. So that's what I'm trying to solve, is that it doesn't matter where you are in the industry. If you're just starting out, you're brand new, I'm going to help you learn how to design networks, right? And make them effective networks to make businesses successful and companies successful, right? Because that's truly what this is all about. It's not about making the network, this spiffy new thing, shiny and golden and diamonds and whatever, unicorns. It's about making that business successful, whatever that business needs to be successful. That's money, or if that's a service it provides. And everything I do is based on that idea, right? And
I will confirm this. I've listened to a bunch of Zig's podcasts and poked around the website too. And all those principles come through in what you do, Zig. So there's the podcast, but you have more stuff to offer.
Exactly. So, thanks. You're always directing me. I appreciate it, Ethan. You're a good man. So you're like, hey, you got to get on course. Yeah. So, I am creating a network design, course. It's a vendor agnostic, certification agnostic course. Now, that doesn't mean that you can't use it for your, other specific certification needs. You can learn all the network design, requirements, principles, fundamentals in the course. It is not done yet, but I'm hoping to have it done this month. And if you want to join the email list to get weekly updates, it's zigbits.tech/network design. And again, the whole point is to solve that goal, right? That gap, meet that gap, and teach everyone how to design networks.
So this month, in case you're in a time machine, it's March 2021. So April 2021, Zig, you're hoping to have that network design course available to folks.
Exactly. Sorry, I think of the time machine, right? March 2021 is my goal. It was supposed to be February. Life happens, and you don't know what you don't know. So all other content, just to be clear, is on zigbits.tech. I don't need to dwell any longer, right? Just if you want to hear more about me and what I'm doing, just go there. You can find the email list. You can find me. You can find me on Twitter as well, Zig_Zsiga, and just reach out. I'm here to help. So just reach out whenever you need.
Great stuff. And thank you for sharing with the Packet Pushers community today, Zig, these deep network design discussions where we really get nerdy with protocols and stuff. Oh, we don't do them every week, but they are fun when we do them. And again, thank you for your time. And if you're out there listening, hey, thank you for your time. We have a lot of content at packetpushers.net. Other podcasts like IPv6 Buzz, which I mentioned. We have the Day 2 Cloud Show, which is hosted by me and Ned Bellavance. We talk to folks in the cloud community about how to do your cloud networking, how to host your compute in the cloud, and all kinds of things related to that, such as automation and career. And there's the Network Break podcast, where we do news and analysis. That's with Greg Farrow and Drew Conroy Murray and more. You can find all of the shows we have to offer, packetpushers.net/subscribe. And we too are on Twitter at packetpushers, and we're on LinkedIn if you'd like to follow us there. We have a free weekly newsletter too. And this is not one of these newsletters like we get your email address and then we sell it. No, we don't do anything like that. We just we help you keep up with what's going on in the networking industry. We feature a lot of blogs that we've read, technical stuff, things that we think are important, bits of news that are worth sharing. That's all at packetpushers.net/newsletter. It's absolutely free. We have a Slack group that you might like to join. It's, again, another freebie for you as a Packet Pushers listener. Packetpushers.net/Slack. Read the rules. We have 3 simple rules about how to participate as a good citizen of the community in our Slack group. Join in. There's over 1,500 network engineers that are participating in that, going back and forth, asking opinions, solving problems, just helping each other out. And it's a joint mix of people that are practitioners and people that are working for vendors. Everybody's just helping each other out, and it's a marketing-free zone. Go ahead and sign up there. Last but not least, remember that too much networking would never be enough.